right, now pay attention, because if you're not going to pay attention, you're going to miss it again. It's an easy question. Let's just use what we learned yesterday. All right, we want to find electric field strength at A. The first thing you're going to notice is that both of these charges, they are the same charges. This means that if there's going to be an electric field strength at A, it's going to depend on whether they're the same charges or whether they're different charges. They're going to have, okay, are they going to have the same electric field directions at point A, or are they going to be different? What do you guys say? Would the electric field directions be different at A, or will they be the same? What do you say? Exactly. Why? Because they're the same charges. So it's completely our choice. You can say that, if this was minus and if this was plus, you could say that E1 is towards the left and E2 is towards the right. But since both of them are the same, it's our choice. So they're going to have the same directions. This means that both of the EFSs, due to the two charges, they're going to add up at A. So in this scenario, it's not really required for us to show that. It's just for our understanding. Now, this charge was 5 microcoulombs. I want to find the electric field strength due to this thing at A. What's the formula for EFS? Come on, guys. What's the formula for electric field strength? Yes, it's F over Q and it is KQ over R squared, but we are going to use KQ divided by R squared. Why? Because we don't have F. As simple as that. So let's find EFS due to this charge. Now it's going to be, let's say this is 1, this is 2. So E1 plus E2. Let's find E1. E1 is going to be equal to KQ divided by R squared. Now let's plug in the values. What is the value of K, by the way? What is K? Hey guys, what is K? What's the value for K? Yes, exactly. It's 9 into 10 raised to the power 9. That's great. The charge over here is 10 into 10 raised to the power minus 6. Why minus 6? Because that's just how we represent micro. Okay, let's extend the line and let's write the number below. Now, here, we're going to write the radius. What is the radius? What should I write here? Let's ask, okay. Are you sure it's 12 centimeters? Exactly. It's not going to be in centimeters. Never forget it. Well, the first step was for you to identify that you have to use this length from, let's say, point 1 to point 3. This is the first step. After that, this is 12 centimeters. Now you're just going to multiply 12 by 10 raised to the power minus 2, and you're going to end up with 0.12 meters. So let's just write this. Now, if we're going to use our calculator, let me use mine and let me find an answer. And the answer should be approximately okay. The answer is 7.5 into 10 raised to the power 5. Najina, were you getting the same answer? Oh, yes. Thanks for pointing that out. Good job. Yeah, mistakes like this happen sometimes. And yes, don't forget the square. You saw me making the same mistake. Now, I hope you guys are not going to make this same mistake that I just did in front of you guys. So yes, once we square it, it's going to be a completely different answer. It's one of the most common mistakes. So yeah. Okay, 10 raised to the power 6 minus 6 divided by 12 into 10 to the power minus 2 squared. Okay, I'm getting 6.25 into 10 to the power 6. Exactly. Hey, Aisha, are you sure this is 26? Because I'm getting 10 to the power 6 here. See? Okay, so Sabina, what do you mean by 4? Are you guys talking about this number? Okay, okay. Look, E is KQ divided by R squared, right? What is K? It's not 4, it's 9. This is 9. This is 9 into 10 to the power 9. So Usman, look, do you see I have written this 1 and I have written this 2. Do you know that we have 2 charges here? Now, listen very attentively or you'll miss the word. We have 2 charges. This means we're going to have 2 electric fields acting at point A. It's not going to be just one. Why? Because when I say I have 1 electric field, I'm saying I have 1 charge. So since we have 2 charges, we're going to have 2 electric fields, right? That's why I wrote E1 plus E2. And that's why I am using E1 right now. And then you're just going to add up the 2 fields and you're going to get the answer. As simple as that. So Key, did you take yesterday's lecture? Key, were you here yesterday? Just a question. Okay. So once the video is uploaded, hopefully you're going to see it. But for now, I'll tell you this. Electric field is force divided by charge. Listen very carefully. Electric field is force divided by charge. Force is 1 divided by a constant, but I am not going to write that constant. The constant is, I believe, 1 over 4 pi a naught. But instead of this, I wrote k q divided by r squared. This is a small q. And when you divide f with q, you end up with this formula, which is k q divided by r squared. Okay, let's find E2. All right. When finding E2, you have to repeat the same steps. 9 into 10 to the power 9, 5 into 10 to the power minus 6, and you're going to get, okay, what is my radius over here? What do I use here? Do I use 10? Do I use 2? Exactly, you use 0.02. Why 0.02? Because you're using 2 centimeters. And you're going to square it, and you're going to get your answer. And the answer from this part here is, I believe, 0.02 squared. Okay, the answer from here, the one that I'm getting is 1.125 into 8, into 10 to the power 8. That's the one that I'm getting. Legina, are you getting the same answer? Okay, that's great. Now, just add up these two things. E is going to be equal to E1 plus E2, and you're going to end up with 6.25 into 10 to the power 6 plus 1.125 into 10 to the power 8. And you're going to get an answer here, which is, just a second, let me add it up. And we have 1.1875 into 10 raised to the power 8. Just a second, 1, 2, 3, 4, 5, 6, 7, 8. Yeah, 8. and you round it off and you get 1.19 or 1.2 into 10 to the power 8. What are the units, by the way? We did this yesterday. Come on. The students who were in yesterday's class, what are the units of this answer? Hey, what are the units of this answer? Is it newtons? What is it? Exactly. It's newtons per coulomb. Don't forget this. So this is the answer. Okay, now write this down and let it sink in. If this doesn't make sense, ask me, because right after this question, I'm giving you a question and you're going to be solving it on your own. So, does anyone have a confusion here? Are you guys with me? Is everything clear? Okay, that's great. When you're done noting this down, tell me, and I'm going to write the next question. All right, so before we erase this, a small addition to that I would like to make. Since we have two charges here, I'm going to make two arrows here. The first one for E1, the second one for E2. This is the direction of the electric fields, E1, E2. Now you might wonder, why does electric field have direction? Well, what is electric field? It's force divided by charge. Is force a vector? Of course, force is a vector, and therefore electric field is also a vector. So never forget this. Electric field strength or electric field is a vector. So electric field is a vector. It's always going to have a direction. And since this is a positive charge, it's having an outward direction. All right, I'm about to erase this. 3, 2, 1, clear. Okay, it's time for me to write the next question. Now make sure you do this one very carefully, and I want an answer from everyone. Let's see if you guys understood the concept. Now, instead of two pluses, I have a minus here, and I have a plus here. So we have two charges, a minus here and a plus here. And again, I have a point A, and I'm asking you to find the electric field at A. And obviously, I'm going to give you the distances here. This is 10, this is 5, and the distance is the same. This is 10 centimeters, and this is 2 centimeters. I am giving you exactly 3 minutes. Right now, it's 22 minutes. When it's 25 minutes, I am going to stop the timer. Okay, time starts now. Start solving this. Key, that's because I just muted myself. You guys have 2 more minutes to solve this question. I just gave you this question. Yeah. And there's 2 minutes left. So yeah, hurry up. And once you're done, send your answer in the chat. All right, one last minute. And it starts now. So in exactly 60 seconds, I'm gonna stop the time. Okay, we have our first answer. Good job. And I'm gonna tell really soon if it's the correct answer. Okay, guys, 10 seconds left. Send in your answers and we're gonna start the discussion. Okay, the time is up. Send your answers. Were you guys able to solve the question? I'll ask you guys individually. So I have an answer from Asman. I have an answer from Lajina. What about the rest? Sabina, Nuvefa, Ahmed, Ki, Aisha, Anika. Are you guys done with the question? Okay, I'll give you a little more time. What about the rest? I have only one answer, and I took like 5 names. Sabina, are you solving? Are you done with the question? Okay, we have an answer from Ki. Great job. All right, I'm giving you guys 30 more seconds. I'll assume that the ones who did not answer are solving the question right now. And I'm going to start the discussion right after that. Okay, last 30 seconds. When the meeting reaches 27 minutes, I am going to start discussing the question. All right, guys, time is up. No problem. What matters is that you guys attempted. And trust me, attempting now and making mistakes now, this is what's going to prepare you for the exam. No problem, Ki. You already sent your answer, so that's fine. Okay, Sabina, are you done? I'm going to start discussing now. All right, let's do this. For those who are not able to finish, or for those who are not able to, for those who are not able to get the correct answer, we're going to see what's the correct answer now. Now, when you started solving this question, the first thing you should have done is this. This is a negative charge. This is a positive charge. Meaning there's going to be two arrows. The first one, make towards the left. This is going to be for E1. This is E1. And the second arrow is going to be for E2. This is going to be E2. Why did I do this? Because electric field is a vector, right? And if electric field is a vector, they're going to have opposite directions because this is negative, this is positive, right? Now, you have to set which side is positive. Now, I think that for me, it's more convenient if I set this side as positive. So I'm just going to go with this as the plus. We always do that in physics. I have set this as the plus. This means, why did I do this? Because this is the greater charge, and there's a possibility, let's see now, but I will assume that it may have a stronger electric field. But let's see if that's the case. Now, EA is going to be equal to the difference in the magnitudes of these two electric fields. So E1 minus E2. All right, let's find E1. E1 is, I believe, going to be the same as last time. Let's see. 9 into 10 raised to the power 9 into 10 raised to the power 10 minus 6 and 12 into 10 raised to the power minus 12 squared. And what do I do here? Do I subtract or do I add? Because that's what's going to decide where did you go wrong. Now, since I literally just made this minus sign, I am going to subtract them. So 9 into 10 raised to the power 9 into 5 into 10 raised to the power minus 6 and 2 into 10 raised to the power minus 2 squared. And yeah, and you should get the answer. So I'm going to do the calculation on my calculator. You guys do on your calculator, and let's see what answer we get. All right, I'm almost done. And 5 into 10 to the power minus 6 divided by 2 into 10 to the power minus 2. Okay, the answer you should be getting is, okay, now this answer is going to be, oh, I shot, you're saying, okay, thanks a lot for telling me that. Yeah, you're right. So the fun thing is that when I was writing it in the calculator, I wrote it as minus 2. So anyway, thanks for pointing that out. Yeah. Okay, the answer I'm getting right now is minus 1.0625 into 10 raised to the power 1, 2, 3, 4, 5, 6, 7, 8. Yes, 10 raised to the power 8. Okay, now I'll explain what this minus basically means. Now, my assumption that this E1 was greater was wrong because the distance right here is huge, right? This charge, even though this is smaller than 10, this charge is closer to A. And that's why this charge is going to have a stronger electric field. This means that if someone would have asked you that, find the resultant electric field, it would be in this direction. So if you would have supposed that this is minus and this is plus, then your answer would be plus. But this minus plus thing, this does not matter. And I think most likely in the mark scheme, they're going to ignore the sign anyway. So your final answer is just going to be this. So this minus, this is just the direction because this is a vector quantity, right? But if I want to know like what's the electric field here, if we ignore this thing right here that I did, then your answer is 1.06 10 to the power 8. So if you get this answer in the negative or you get it in the positive, that doesn't really matter. That's what my teacher told me in my class when I was learning this back in the day. And this is what I am telling you. This minus sign won't matter. My teacher also told one thing, minus E1 plus E2. Even this doesn't matter. You could do even this, minus E1 plus E2. I hope this makes sense. If anyone has a confusion, you can ask. And the units NC minus 1. Okay, so Key says he replaced for E1 in the bracket with the minus 10 itself. Yeah, that's great. Okay, so note, if you guys are done, I should move on. So if you're still noting this down, okay. So Aisha says, so won't we multiply 5 into 10 to the power minus 6 with 2? Hey, so why would you multiply it by 2? I mean, this is one charge. Are you talking about this 2 right here? This is just a number if you're talking about this. So this is just a number. This is not, I see, this causes confusion. Apologies. 1, 2 means that this is charge 1 and this is charge 2. So that you could understand E1, what is E1 and what is E2. That's why I wrote 1 and 2. If I did not write this, you guys would be confused. Okay, so what is E1? What is E2? Anyway, so I'm about to clear this. Are you guys done? Or is anyone still noting down? Okay, I'm about to clear this. Okay, let's do the next part of the same question. In fact, let's just minimize this so that we have the answer here as well. Okay. Hey, why didn't it? I guess it's some kind of weird problem. Just a second. Okay, let's minimize this and it's here. All right. The next question is going to be the same part of this question. So this is A, and it's going to be a different part for the same question. They're going to ask you, find the force on a 2nc charge placed at a point placed at point A. Okay, now do this question. I think this is a very easy question, and yeah, start solving. I'm gonna give you guys like 2 minutes because I think this can be solved. In fact, I'm gonna give you 3 minutes, and let's see who answers it first and who gives the correct answer. Okay, the time starts now. Start solving the question. Yeah. This is 2nc. 2nc. 2 nanocoulombs. Okay, Legina has an answer. That's great. 2 more minutes for the rest. All right, we have 3 answers. We have 4 answers. Good job. Your answers are all same. So I am most likely you guys are going to be right. Okay, so I'm going to give 50 more seconds. I mean, 50 more seconds are left. So the rest, this is your last minute. 30 seconds to go. All right, good job, guys. 5 more seconds, and I'm going to start explaining where you might have gone wrong. Now, you guys know that this is the A part, and this is the P part. And in most of the scenarios, the P part is going to be like 2 marks, maybe even 1 mark. And this part is like 3 or 4 marks. Now, just imagine, we know that there's a formula for force. Force is, what is force? K, Q divided by R squared, right? Now, I assume that most of you, what you did was you did F1 minus F2, something like that, right? And then you just subtracted this, and that's just a long method. Now, I am going to assume that at least one of you did what I am going to do right now. Now, it's an advice whenever you are in this situation, follow this. So whenever they ask you this in the B part, like find the force on a 2 Newton charge, on a 2 NC charge, check this out. What is the formula? What is the formula for electric field? E is equal to F divided by Q, right? So I want to find the force, right? So F is EQ. Do I have the electric field? Yes. Do I have the charge? Yes. Just multiply 1.06 with this, and you're going to get the answer. As simple as that. Exactly. And this would literally take you like 1 minute. The meeting is going to end on its own, by the way, and then we're going to continue in the next meeting. So whenever you are in a situation where they ask you this in the B part, the force in the B part, you are going to use F is equal to EQ. But if this was asked in the A part, you're going to use KQQ divided by R squared. I hope this makes sense. All right, so what's the answer again? Yeah, it's 10 power minus 9. Oh yeah, thanks for pointing out. Yeah, it's minus 9. It's not minus 6. Yeah, it's nano. Yeah, you're right. For a second, I had micro in my mind. Yeah, so it's minus 9, and the answer you should get is 0.212 and 0.21 newtons in 2 SF. All right, so I hope this makes sense. You guys can ask any questions which you have in the next meeting because the meeting is about to end. I'm sending the link right now. All right, as promised, I'll explain you what is permittivity. Let's keep this aside and don't forget this. Okay, now, this is more of a note. It's not a concept related thing for A levels, not for questions, but you're just supposed to know this. Now, as I said that day, permittivity comes from the word permission. Now, what is E naught? I mean, it has a nice value. By the way, what is permittivity? Does anyone remember the number? Relative permittivity. What's the value, by the way? Hey, does anyone remember the value? Come on. What's the value for permittivity? I mean, you guys know K is 9 into 10 to the power 9, right? And you know that we found E naught from, we found K from E naught. Hey, does anyone remember? Exactly. Good job. It's 8.85 into 10 to the power minus 12. Don't forget it. And if you want to find K, you know that K is 1 divided by 4 pi E naught, and you're going to get the answer. Anyway. Right, so the permittivity we use is only true for vacuum. There's really cool thing that I wanted to share. Now, permittivity of air at normal pressure is about 1.005 times that of vacuum. For water, it's 8 times that of vacuum, meaning in water, it's 8 times harder or easier as compared to the vacuum. So the force between, just a second, that's like I clicked the wrong button. Okay, we're back. Apologies. So, do you guys know that NaCl, right? Do you guys know about this, right? You studied this in chemistry. Now, this has nothing to do. Oh, okay, Usman says, what is this 8.85 value? So, Usman, we did this yesterday. This is a constant, relative permittivity. And yesterday, I also taught you a formula, E into A, and we had permittivity there as well. Okay, so you guys know that NaCl dissolves in water. Why is that? Because electrostatic forces of attraction between Na ions and Cl ions are reduced. Now, look at this. Na is a charge too, right? I mean, positive ions, right? So can I say Na, these are positive charges, right? And Cl, these are negative charges. Now, check this out. Why is it that in air, in air, why is it that NaCl is a solid? Because they have some kind of attraction, right? There's an electric field, there's a force between these two charges, right? There's a force that attracts these two charges together. Isn't that true? Now, why is it that all of a sudden this force becomes weaker in water? Why does NaCl dissolve in water? What does it mean that NaCl dissolves suddenly in water? Well, that's because NaCl becomes aqueous, or like, liquid. It's not liquid, but it becomes aqueous. Why is it that? Because these forces weaken. Forces, electrostatic forces of attraction, they weaken. And you know why does that happen? Because in air, we have a different permittivity. In water, we have different permittivity. In vacuum, we have different permittivity. So if I were to say that, okay, so this relative permittivity, this is the permittivity in vacuum, then if I would multiply this by 1.005, that would be the permittivity in air. So in air and in vacuum, there isn't much of a difference. But in water, there's a lot of difference. The permittivity of water is 8 times more than that of vacuum. This means that in water, your charges are going to have weaker force. It's not going to be as strong as it was in air. Now, this is a little bit of chemistry here, but my point was that permittivity is what defines how strong the charges can act on each other. Just a little conceptual thing. So the next time you study chemistry, know that physics and chemistry are like brothers. There's a very strong connection. I hope permittivity makes more sense now. But, like just for the questions, you're going to have to remember this. Now, I hope this made sense. Are you guys with me? Did this make sense at all? Okay, I hope that's true for everyone. Now, the other day, I told you guys something. I said that inside a charge, electric field is 0. And all of the charge lies at the surface. It lies on the surface. This also means that all of the effects caused by this charge, they are unseen inside. But how did humanity find that out? How did scientists figure that out? Well, I have a very interesting thing to tell you guys. Just give me a second. Let me find what was his name again. Yeah, Faraday. You guys remember Faraday, right? So, all right. The fact that there's no electric field inside a closed conductor when it contains no charged bodies was demonstrated by Faraday. Now, this scientist, you know what he did? He literally made a cage, a wire cage. So imagine that this is a cage, there's a lot of wires here. He made a wire cage and he placed himself inside here. So this is a wire cage. And he sat inside with a spectrometer. Now, with an electroscope, not a spectrometer, with an electroscope. Now, electroscopes, they tell you all the stuff about electric fields. They're electric field detectors. So he charged this cage. Now, back when he sat inside it, there was no charge. Now, he charged this cage, and this cage was filled with charge. I mean, just imagine like large amounts of charge on the cage. If you were to touch this, I mean, you would be a goner. But he risked, and he sat inside. Now, there's a really fun thing. Now imagine that he has electroscopes outside. Now these are going mad. They're like, oh my God, this is a huge charge. They're going crazy while he sat inside having a nice time. Literally, he felt nothing, like literally nothing. And that's how he proved that inside charged bodies, there is no electric field. So there's no electric field. And that's why when we made the graph that day, it was like this, and there was nothing here. I hope it makes sense. All right, let's do the next thing. And yeah, the next thing is going to be electric potential. Let's do this. Okay, now just like we studied, this is going to be the last thing we're going to do for today. I'm just going to introduce electric potential and we're going to continue on Monday. Now, pay attention. Back when we were learning gravitation, we studied something called gravitational potential. Now we're going to be learning electric potential. Now, a lot of students, what they do is they confuse this with the potential difference. This and this, they're not the same. They're different. Yes, we cannot deny the fact that both of these units, they are volts. Both of them are in volts. But this is potential difference and this is electric potential. All right, let's write the definition for this. Now, electric potential is the work done. Now, just pay attention to how similar these chapters are. It is the work done in moving a unit positive charge from infinity to a point in an electric field. Now, work done in moving a unit positive charge, doesn't it remind you of work done in moving a unit mass from infinity to a point in a gravitational field? But now they're saying unit positive charge, and again, infinity to a point in an electric field. However, don't get it confused with the infinity concept. We don't have infinity here, and that's the biggest difference. Back in gravitation, we had infinity, and that's how we used to define the electric potential. This time we don't have the infinity. Yeah, we have the infinity, LOL, but it's different. It's different. It's not like that one. Let me explain how. Okay, so I use the incorrect words. Basically, over here, we have the infinity. But back then, at infinity, what I actually wanted to say was that here, the phi was 0, right? And so I used to say that all of this potential right here, the gravitational potential, all of this was negative. But over here, it's not the same. That's what I actually wanted to say. Apologies for the wrong words. Now, the unit for this is volts. Yeah, volts. That's the unit. Okay, now the formulas. If we're talking about a positive charge, all right, so if we are talking about a positive charge, then this is going to be equal to kq divided by r. But if this is a negative charge, this is going to be equal to v is equal to minus kq divided by r. And that's pretty much it. As for all the other stuff, when we go into the chapter, we're going to do all of that stuff tomorrow. So, okay, sure. Now this is going to be it for today. Just a second, I'm going to explain you that. Okay, now electric potential, just like gravitational potential, they're very similar. So electric potential. Okay, now electric potential is very similar to gravitational potential. It is the work done in moving a unit positive charge from infinity to a point in an electric field. Now, back then, we used to deal with masses. So in the gravitational chapter, we used to say, work done in moving a unit mass from infinity to a point. But this time, it's literally the same thing, but there's a lot of differences, just like I said before. You can say that it is somewhat the same thing, but for electricity. Now, the formulas for this, what you need to know for today is just this, that for a positive charge, V is going to be equal to plus kq divided by r. And for a negative charge, it's going to be equal to minus kq divided by r. Okay, so Legina, what does infinity mean here? Okay, so infinity, generally, and here, this is that point where if I have a charge, its electric field doesn't act. Really far from it. That's the infinity. You know what? For now, just do this. I watched a very good video. I think, at the beginning of this year, and it was a very good explanation for electric potential. So I don't have the time today anymore. So I'm going to explain all of that tomorrow. So for now, just remember this definition, these two formulas, and this infinity. This is the same infinity as before, except I said there are some differences, but I'm going to talk about them tomorrow. Okay? I hope everything makes sense now. I know it might be a bit confusing right now, but I'm going to explain everything tomorrow. Oh, I mean, on Monday, right? Monday, yeah. Oh my God, why was I saying tomorrow? Okay, yeah, look. So on Monday. All right. See you guys on Monday. Have a nice weekend. Make sure you open the topical and solve some questions. If I find some good questions, I am going to share it with you guys. All right. See you all on Monday and have a nice weekend. Okay, so Usman, are we preparing for October, November? So Usman, when I say I am preparing, we're doing past papers and we're doing the syllabus. Ideally, yes, we are. Right now, our speed is normal. I originally wanted to finish the syllabus by the end of August, but that might not be possible. But we will finish, inshallah, before the exams. I can promise you at least that. We're going to finish before the exams. So your syllabus is going to finish before the October and November exams. But if you want to ace the exams, do a lot of past paper because we don't have much time. That's why we don't do a lot of questions. But considering our situation, we still do decent amount of questions. Anyway, have a nice weekend and see you all on Monday. Allah Hafiz, guys. I'm ending the meeting now. Bye.